we're going to show that if a is an integer that satisfies this initial condition, a has to be the product of two other integers. It'll be natural numbers most of the time. There are some negative integers that would satisfy this condition, namely -8 and -5, I guess. But a has to equal to the product of two integers x and y, such that x, where x minus y would equal 6. Good, okay? And again, x and y are integers. Now this is a concrete example right underneath. Notice that right here we would have, 324, which is 15, 315 plus 9 is equal to 18 squared. Okay? So this statement's certainly true right here. Now, what about 315? Well, notice that 315 is equal to 21 times 15. So this is just one, it's not a proof, but it's one concrete example that makes you believe it's what's going on here, or we maybe want to check into a little bit further. 21 minus 15 is 6, right? So this is an example of a specific set of integers that meet the conditions. Okay? Now let's just prove it in general. It's not particularly difficult. The square root of a plus 9, a member of n, means that the square root of a plus 9 is equal to some natural number n. Okay? We'll just call it n. And you can almost see it immediately here. This means that a is equal to n squared minus 9. This is super familiar result, difference of two squares factoring formula here. So that's n plus 3 times n minus 3. All right. It's really a very straightforward problem, no special results or anything. And notice that, and you can see the difference of those two numbers is 6, but I'll take the time to write it out. N plus 3 minus n minus 3 does equal to 6. And so we can go ahead and write down QED here. Thus we've demonstrated. Now, I did want to make one comment. At the very beginning here, a could be -5, for example. In other words, in this, we don't have to confine it to just integers. There's a couple of natural numbers. A equals -5 would satisfy this statement, right? Because -5 plus 9 is 4, and the square root of 4 is 2, which is a natural number, right? And notice that -5, or let's see here, does this work? -5 minus, oh, I'm sorry, yeah, 1 minus -5. 1 and -5 are divisors of -5, right? And we have 1 and -5 has a difference of 6. Okay. Now I guess that's, yeah, that meets the criterion. So, and also -8, something similar would work out with -8. But other than -8 and -5, a would have to be a natural number outside of those two special cases. But those two special cases do work. But anyway, the general proof, very, very straightforward. Just recognize when you do this work right here, when you just square the given information, you get a very natural looking difference of two squares results. You get this factorization, and it's clear that these two factors are always going to differ by 6. So that completes the proof, folks. Thanks for viewing.